Module 5, the muscular system, histology and physiology. Energy and skeletal muscle fibers. You already know that for muscles to contract, they need lots of energy. The energy they utilize is stored within ATP molecules. ATP is made in the cells during cellular respiration. The cells take adenosine diphosphate, or ADP, and a phosphate group plus some energy and make adenosine triphosphate, or ATP, storing that energy within the molecule's chemical bonds. When the cell needs energy then, it will break up ATP molecules into ADP and phosphate groups, releasing that energy. Remember that a muscle fiber is a special term for a muscle cell, and cells can store ATP energy. There are three main ways that ATP is produced in a skeletal muscle. First, aerobic respiration. This is a process comprised of many steps, taking glucose, reacting it with oxygen, and releasing energy from that reaction. That energy then is used in the reaction with ADP and phosphate to make ATP. You may remember that aerobic respiration burns one molecule of glucose and produces 36 total molecules of ATP. That's lots of ATP molecules. And the waste products of this complex process are only carbon dioxide, which you exhale, and water. But aerobic respiration is comprised of 4 lengthy steps and requires lots of glucose or other food plus lots of oxygen. Aerobic respiration sometimes can't happen fast enough for the muscle fibers. It's best used to produce a good supply of stored ATP energy when the muscle fibers are resting or if they're mildly in use. For example, when you're warming up your muscles before playing a sport. But sometimes muscles need short bursts of lots of energy. Your text compares this to sprinting versus long-distance running. You see, long-distance running requires you to keep a steady pace for a long time. But with sprinting, you need to run as fast as possible over a much shorter distance. For sprinting, your muscles need lots of energy all at once. Aerobic exercise needs oxygen, so the faster you can get oxygen into your body through your blood system and into the muscle fibers, the faster your muscle fibers can make ATP. But with sudden, intense exercise like sprinting, you just cannot get enough oxygen to the cells fast enough. So what do your muscle fibers do? Well, if they have had lots of time to rest before you use them, they can make an energy bank. The cells utilize aerobic respiration to produce a chemical called creatine phosphate. This is a high-energy molecule that is stored in skeletal muscle. In a special reaction, creatine phosphate gives up its phosphate to ADP, quickly producing ATP and creatine. This is a fast reaction which can rapidly convert ADP to ATP. So if a muscle fiber has ATP stored via aerobic respiration but cannot make any more, it begins to make creatine phosphate. This way, once the existing ATPs are broken down for energy, they produce ADP and phosphate. Those molecules have to be converted back into ATP for the cell to have more energy. If there isn't much time available or not enough oxygen or glucose for aerobic respiration, then the muscle fiber can take that creatine phosphate to make more ATP in a quick reaction. It doesn't need oxygen or glucose, so the muscle fiber can begin making ATP right away. So creatine phosphate is kind of an energy reserve made by muscle fibers in case they need a quick supply of ATP. But there is one drawback with this method. Muscle fibers can only store enough creatine phosphate to produce enough ATP for about 10 to 15 seconds of strenuous contractions. That's great for sudden, quick energy spurts, but only will work for a short duration. What happens if that sudden muscle contraction needs to continue to go on beyond that 10 to 15 seconds? There's no more creatine phosphate to make ATP, and the muscle fiber is using up the ATP much faster than the slower process of aerobic respiration can replace it. Do you just collapse? Thankfully, no. There's one more way that cells can produce ATP. It's via anaerobic respiration. You may remember that aerobic cellular respiration is a several-step process. Well, anaerobic respiration is the first step of that larger process. It's given the name glycolysis, where a glucose molecule is broken down into 2 pyruvic acid molecules, and that produces 4 ATPs. Now, it requires 2 ATPs to get started, so there's a net gain of 2 ATP molecules from this chemical reaction. Notice that oxygen isn't needed for this process. Since there is no oxygen present in the muscle at this point, the pyruvic acid molecules are converted into lactic acid, which diffuses out of the muscle fibers and into the blood. So the slow several-step process of aerobic respiration produces 36 net ATPs using one glucose molecule and oxygen. But if there is no oxygen, the cells can still undergo anaerobic respiration on that glucose molecule, quickly making 2 net ATPs. That produces a lot of waste with the pyruvic acid molecules, but no oxygen is necessary and it can happen quickly. Therefore, if you're doing a rapid sprint, your muscles first begin to utilize the stored ATP within the muscle fibers. They're also able to make some more using creatine phosphate. That's enough for about 3 solid minutes of sustained exertion. But eventually the creatine phosphate and the ATP are used up, and it would take too long for the muscle fibers to wait for the bloodstream to bring in more and more oxygen. So they undergo anaerobic respiration to produce a quick supply of ATP. But that creates a lot of lactic acid. If you continue to exercise at this point, the lactic acid begins to build up because it cannot diffuse out of the muscle into the bloodstream fast enough. So it stays in the muscle tissue. And that's not a good thing. You see, lactic acid is bad for muscle, causing muscle fatigue and blocking up the workings of the muscle fibers. If you've ever watched track and field races where sprinters run at rapid speeds for longer than that 3-minute duration, what are they like when they reach the finish line? Well, they certainly don't look like they can pop right into another race, do they? That's because they've exerted their body pretty strenuously. They're breathing heavily for quite a while afterwards to replenish all the oxygen that their muscles have used up. They have to repay their oxygen debt, so to speak. This is because during the race, all the ATP and creatine phosphate was used in their muscle fibers. They have to be replenished via aerobic respiration. And what does aerobic respiration need? Among other things, oxygen. Additionally, because of the anaerobic respiration, there was a buildup of lactic acid in the muscle, and it needs to be removed from the area. Therefore, it has to move into the blood to be filtered out by the liver, and that requires more energy. So your muscles really need to continue to work to build up those ATP stores again.